Hello, welcome to another lecture on stacks. And in this lecture, we'll be talking about multiple stacks and the application of stacks. Multiple stacks, before discussing it, it's important that we revise what we have seen so far. We have seen the representation of stacks in arrays and linked list. In arrays, we said a stack has got the basic operations of pushing and popping the elements. And when we have arrays, we need to tell what is the maximum stack size, that is how many values can a stack have. So when we are calling a push function, basically an element is getting stored on the top of the stack. If we are pushing another element, it is coming on top of the previous element, third element coming on top of the second element, and so on and so forth. And the place where the element is to be inserted is managed with the help of a variable that is called as a top variable. This top has the current location of the newly inserted or newly pushed data. If we are calling a top function, then the value at the top location would be displayed. If furthermore we are adding the elements, that is pushing the elements like D, as far as there is a space in the stack will get populated by these values. We can even push E, but the sooner we push F, now there is a problem because the maximum stack size, that is 5, has been reached. No new element can be added onto this stack now. Only it can support the top function to tell you about the topmost value and pop functions which can not only return the value but also delete the values from the array. So this push function over here is called an overflow function because already stack is full and no more elements could be added onto the stack. If we pop, then the topmost element is getting deleted. The new top element is now D. Again we are calling pop function. D is getting deleted. Pop C, pop B, pop A. Now there are no elements left in the stack. That means the value of top is equals to 0 right now. If we are calling the pop function now, when the value of top is 0, now this condition is called as the underflow condition. Whatever data structure we use to implement the stack, underflow will be there. It is overflow that could be controlled, right? And we said that the operations of adding, that is pushing and popping the elements from the stack, is constant time. The limitation is that you have to tell the maximum stack size at the beginning itself, which generally in case of static arrays is not modifiable. The problem over here is what stack size should you opt. If you are taking a very small stack size, then it is quite probable that frequently you will be running into the overflow conditions. Managing overflow will require initialization of array of the twice the size of the existing array and then copying of elements. And I told that this is an expensive operation. Therefore, we don't want our programs to overflow frequently. For that, we can either take a large space in the array. If you are doing that, then there is a good chance that a lot of the space will be unutilized for majority of the times the program is run. So there is always a trade-off. Because of these problems, more suggestions were there. One of them was that we can implement the stack with the help of the linked list. Another way is multiple stack. Multiple stack says that you can have a large size for the array, but instead of implementing just one stack onto that array, it is preferable that you can implement 2 stacks on that array. It is increasing from 0 towards the end. So the top, it is growing from left to right direction, and there is another stack B that is growing from right to left direction. That is, it starts with the nth location and then n-1, n-2 and so on and so forth. So this way 2 stacks could be managed onto the same array. So we can have a large array, and in this way we can utilize most of the space. Another suggestion is that we can divide the array into small blocks, and each block could be allocated to a different stack. So stack A may be populated from left to right direction in this section, then stack B, stack C, so on and so forth. So we can have multiple stacks within a large array. So this way we can utilize most of the spaces and we may reduce the overflows as well. Applications of stacks. Now applications of a stack, the first one is recursion, and we have seen recursion in greater details in the lectures before the lockdown. And there we have already discussed about factorial, Fibonacci and Tower of Hanoi. You can refer to these things from the reference 2 that is mentioned in the slides. The second application here is decimal to binary conversion. And you know that decimal to binary conversion, you need to have a number, a decimal number, for example 10, and then you divide that number by 2. Whatever remainder you get, based on that remainder you tell what is the binary of that particular decimal number. So here, as far as that number is larger than 0, it will have a binary. So for binary, what we do is, if there is this stack, we can take two variables, one for asking the number from the user, the other is the top variable, and by now you very well know what is the use of the top. If we talk about this loop, then while num is greater than 0, num is equals to 10 right now, top plus plus, top is initially 0, so I want my top to point towards the first blank location on the stack, so top plus plus, so the value of top becomes 1, and it is at 1 that I push the remainder of the number when I divide the number by 2. So I am using a modulus operator. This operator gives me the remainder after dividing the number by 2. So 10 divided by 2, the remainder is 0. So I'll push a 0 at the first location. Then I reduce the number by 2. So 10 upon 2 is 5. So new number is 5. 5 is still greater than 0. Top plus plus, top moves to 2. Here it inserts the 5 divided by 2. The remainder is 1. That is 1 is inserted or pushed. Number is further reduced. 5 upon 2 is equals to 2.5. But you know that 5 is an integer, 2 is an integer. The two integers are operated upon in any programming language. They will always result in an integer output. From 2.5, we will take away 0.5 and we will take 2 as the integer portion. So the new value for num will be 2. 2 is greater than 0, top plus plus. 2 divided by 2 is 0 remainder. So 0 will be inserted at 3. And last of all, 2 upon 2 is 1. 1 is still greater than 0. So top moves ahead. It stores 1 mod 2. 1 is divided by 2. So when you divide 1 by 2, so 2 goes 0 times and gives you the remainder 1. So 1 will be inserted at the top position. So this way, a stack has been populated. Now if you want to print the binary, then you see that the binary is read from top to bottom. And this is what basically stack does. The top is already pointing towards 1. So we want that until unless top becomes 0, all the elements from the top position to 0 will be printed. So I can write a while condition that while top is not equals to 0, print %d pop. Pop is a function that not only returns the top value but also decrements the value of top. So pop will make sure that the top is decremented. So from 4 it reaches 0 gradually, and every time it is decremented, pop will return the value that has been deleted, and that value would be printed by %d. So this way we can have the output as 1010, and the decimal has now got converted to binary with the help of a stack. Another example is balancing of brackets. Now balancing of brackets is a very important task, and especially in the compilers. So when you are compiling a program, many times you must have got an error of like there is a mismatch in the brackets. So what happens over there? If you have opened, suppose 3 number of brackets and you have closed 3, it is fine. But if you have closed 4, there is a imbalance in the brackets. If you have opened 3 and closed 2, there is an imbalance in the brackets, right? So for example, here there are 4 expressions written. First expression, bracket a plus b, bracket closed, multiply by c. For every left parenthesis, there has to be a right parenthesis, right? In second one, if you see, there are 2 left parentheses, but there is only 1 right parenthesis. That means there is an imbalance in the brackets. How can we use a stack to identify if there is a balance or imbalance in the brackets? So if I am getting a left parenthesis, I will be inserting it or pushing it into the stack. The sooner I am getting a right parenthesis, I will be performing the pop operation. So a stack will only be populated with the brackets, and that too left parenthesis. The sooner you get the right parenthesis, you pop. If the top value turns out to be 0 at the end of the string or at the end of the expression, that means the number of brackets are balanced. Okay, so let's see how to do that. If I'm considering this to be a string, that I can write a while loop which access for all the elements of that string from left parenthesis to the last, that is null character after C. And if my character in this string is equals to the left parenthesis, then I will push. If it is a right parenthesis, then I'll pop. So let's take an example. So in the first expression, if we talk about, there is this left parenthesis. If str of I is equals to left parenthesis, so this condition would be true. You push it in the stack and the left parenthesis have come in. A, plus and B are three other characters that you will get. For these three characters, you have not defined any function over here in the while loop. Therefore, nothing will happen. Then you will get a left parenthesis. So this condition will be true. When this condition is true, you pop the element, that is, you take the element out of the stack. Now, after you have traversed the complete string using this while loop, your program controls comes down. Now you will check what is the value of top. The value of top over here is 0. If it is 0, that means we have got a balance in the number of brackets. Now check the same program for condition 2. In condition 2, left parenthesis, push. You have pushed left parenthesis. Then again, you got a left parenthesis. You pushed it. A, plus and B are three characters for which there is no operation defined, so you won't do anything. Then you get the right parenthesis. Right parenthesis means you have to pop the left parenthesis, so it has been popped from this stack. Now this string ends, the while loop ends, and no more right parentheses are there. So if you compare the value of top, is it equals to 0? It is not, because top is pointing towards the location 1. If it is not equals to 0, that means the brackets are not balanced. Similarly, in the third condition, if we talk about, there is a left parenthesis, so pushed. Then A, plus and B are three characters for which nothing is defined, so no operation will take place. Then there is right parenthesis, so there will be a pop operation, and see from the stack, the bracket has gone. Now at the end you will get a right parenthesis, so this if condition will again be true. So you will call a pop function. Now if you call a pop function on an empty stack, this is an underflow condition. For handling the underflow, I can add this condition over here, that if a string is equals to right parenthesis and top is not equals to 0, then only call the pop function. If a string is equals to right parenthesis and the top is equals to 0, now this condition is not written, you have to write that condition. In that you have to assign some value of the pop such that not balance is getting printed later on. Fine. So I have not written the complete program. This is just a short snippet to explain how stack is used for balancing of the brackets. Okay. Let's look at the fourth condition now. In fourth condition, you have got a left parenthesis, so a push operation is called. Then you have got another left parenthesis, another push operation is called. Then for A, plus and B, nothing will happen. There is a right parenthesis. For right parenthesis and the top is not equals to 0, yes, it is true, you call the pop function, so one of the brackets is popped. Then for asterisk and C, nothing will happen. There is another right parenthesis and the top is still not equals to 0, therefore once again you will call pop. The left parenthesis would be deleted from the stack. Then after plus you get a left parenthesis, so again there will be a push operation, so stack will be populated by a left parenthesis, and after D there is once again right parenthesis and the top is not equals to 0, therefore this will be popped from the stack. Now once this while loop has completed, what is the value of top? The top is equals to 0. That means there is a balance in the brackets. This is the most simplest task that I have told you with regards to balancing of brackets. Actually, when you need them for compilers, you just don't have to do it for the parenthesis. You have to consider the braces, you have to consider the parenthesis and the square brackets, everything, and then the order in which they are occurring. Because if square bracket is opening, you cannot have a parenthesis over here. You cannot perform the pop operation then you have to have many other conditions to be met in order to check if the brackets are balancing or not. Next task is infix to postfix conversion. Now first let's understand what infix is. So you know operators, addition, subtraction, division, multiplication, there are many other operators available, and these are all called binary operators because they act on two operands. The general convention of representing any equation mathematical form is that if you want to add two numbers, you write a plus b, the operator comes in between, and this notation is called as infix notation when the operator is in between the two operands. For example, if you want to subtract, c minus d is infix because the operator is coming in between. E into f, operator is coming in between, so it's also the infix notation. Prefix says that if you want to add two operands, you first have to mention the operator and then the operands. Pre means before. So the operator comes before the operands. So plus AB, minus CD and asterisk EF are just a representation of their counterparts that are written here in the infix notation. This prefix was proposed by a Polish mathematician, therefore the other name for it is Polish notation. Postfix is the reverse of the Polish notation. In this, you first write the operands and after operands the operator would be written. So if you want to add a and b, then it should be written like a and b plus. If you want to subtract d from c, then cd minus. So operator comes at the last. Okay. Now if you want to convert any infix to prefix or infix to postfix, how will you do that? Let's take two equations. You will see that infix is a plus b into c. Now if I ask you how many operands are there, you will tell me 3. 1, 2 and 3. How many operators are there? There are two operators, multiplication and addition. Now if I ask you the question that which one of the two would be operated first? So C has got a precedence table. You will look into the precedence table and you will tell me that multiplication is the operation that you have to perform first. And if you don't know the precedence table of C, no problem. Bottomus also says that the multiplication should be done first. And so you have to calculate the product of B and C first. So the first operator is pointed by the blue. If you want to convert this into prefix, what you are supposed to do? You have to take that operator out in the left hand side direction. That means you have to write the operator first and then the operands. So this will become A plus star BC. The second operation that you have to perform now is the addition operation. Once you perform the addition operation, this addition sign would come towards the left hand side. So the resultant notation in prefix would be plus A into BC. Similarly, if you look at this expression, we'll see that the priority is set by the parenthesis here. Parenthesis tells me irrespective of the preference of multiplication operator over the addition, it is addition that has to be performed first because it is enclosed between the brackets. So in C precedence table, brackets have got higher precedence. Therefore, anything that is within the bracket would be solved first, and same goes with the bottomers as well. So here, the first operation that I have to perform is addition, and therefore the result of A plus B would be plus AB into C. Second operation is multiplication. So the result of this expression would be that the multiplication would be coming towards the left hand side. So it will be star plus ABC. Now you'll observe that while you are representing any notation in prefix, any expression in prefix notation, you need not have brackets over there. There is absolutely no requirement of brackets in these notations because these notations speak for themselves and they tell you that which of the operations would be performed first. For example, if you look here, addition needs to have two operands. It is getting one operand immediately, but there is no other operand present. Instead of operand, it is getting an operator. That means plus cannot be performed. You come to the asterisk, that is multiplication operator. After it, you get two operands. That means you can complete the multiplication operation. Therefore, the product of B and C would be calculated first, and then later on the result of this will serve as the second operand for the addition, and therefore addition could be performed. And now if you look at this expression, you will find that multiplication cannot be performed. Why? Because it is not getting the operand immediately. Instead, it is getting the operator. If we look at the operator plus, it is getting two operators consecutively. Therefore, plus would be performed on A and B. Therefore, we will get the result a plus b, and then this result of a plus b can serve as the operand for the multiplication operator. Now you can perform multiplication, and this is what exactly infix was doing. It was adding first and then multiplying. So without brackets, prefix is pretty much telling me that which operator has to be in what priority order. If we convert infix to the prefix, then the procedure is exactly same, but you have to keep in mind the operator should come after the operands. Here also the precedence of multiplication is more than the addition, therefore the first operation is multiplication. B into C will be represented as BC star in postfix notation. Then the second operation is plus. So operand 1 and operand 2, A, BC star plus comes out towards the right hand side. Similarly, if you solve this, then A plus B would be evaluated first. So it will result to AB plus, then multiplication. So AB plus C star is the result. If you take another example with the numbers, if my A is equals to 7, B equals to 2 and C equals to 4, then 2 into 4 is 8. So BC star is representing the product of the two number, and then ABC star plus is representing the addition of the product and the operand A. Now let's see some more examples. Here we will discuss that how can I convert an infix to the postfix using a stack. I know the result of this because we have calculated in the previous slide. So for that you will have to create a matrix. Here the first column is representing the input characters. That is, input is infix notation to A plus B star C, A plus B star C. Then whatever operation we are performing on the stack, so stack elements are written in this column. If we are performing any operation on the stack, it is written over here what operation is being performed, and this is the postfix expression, the output that we want. This is the output over here. Now the stack has to be initialized to the left parenthesis, and you have to append a right parenthesis towards the end of this infix. So this is acting as the sentinel which tells you where to stop, right? And this matches with the initial value of a stack. So it is like a stack has opened a bracket and the infix notation is closing a bracket, and within the bracket there is an expression. So what happens, how does it work? A stack can only maintain the order of operators. The job of a stack is to tell me that if an expression has more than one operator, then which operator will be having the preference over the other. Therefore, it is the only operators that will be pushed or popped from the stack, and operands have no role to play over there. As soon as you are getting the operand from the input, you directly write it down in the postfix expression. So if you are getting A, I will be calling postfix expression as PFE. So you will be directly writing it to PFE. Then you got a plus sign. In this plus sign, since I told you that the operators will be inserted into the stack, therefore you will perform the push operation and plus will come into the stack. You got a B. Stack has nothing to do with the operands, so it is directly printed as a result in the PFE. Then you got multiplication. Multiplication would be pushed but not casually, because the order is also important. Okay, which operation of the two will be given the more preference. So initially you had a plus operator. The new operator you are getting is a multiplying operator. Multiplying operator has got more precedence. So it is like a passenger train is standing on the platform and a Shatabdi train is coming from behind. As a station master, what would you do? Would you allow the passenger train to move, or would you hold it back and allow the Shatabdi to go in front because Shatabdi has got the preference? It is the first class train. You will allow Shatabdi to pass and you will hold the passenger train. Similar is the case over here. A stack is a station, and whenever you get a high priority operator, you keep it at the top position, and the operation of plus will be held back. You are not performing the plus operation right now. Then you got C. C is directly mapped to PFE. Then you got the closing bracket. So whatever is there from this right parenthesis until the left parenthesis will be popped. So when you are popping from the top, right? So in these two, the higher one is on the top. That's what we did over here. That's why we checked it over here. Now when you are performing the pop operation, multiplication will be popped and appended to the postfix, and then plus will be popped and appended to the postfix. You have to discard the brackets because I told in the previous slide, postfix expressions do not need parentheses. So you have to discard the parentheses altogether. So this is the final result. Let's see another example. In this example, the brackets are setting the priority for the plus operator. So let's see how it is handled. Again, stack is initialized with the left parenthesis, and you are as sentinel appending a right parenthesis in the input string. Input string is left parenthesis a plus b, right parenthesis multiplication c. This is not an operand, therefore it will be pushed into the stack. So stack has got two left parentheses. A is an operand directly to PFE. Plus is an operator inserted or pushed into the stack. B an operand directly to PFE. Bracket will make sure that all the operators that are there in the list until the first left parenthesis is met will be popped. Therefore, A will be popped and printed. If you compare this with the previous example, the plus was not popped when multiplication came. Why? Because there was no brackets involved. Here, the presence of these brackets has made it possible that everything before this right parenthesis will be popped and appended to PFE. So plus has now come to the PFE. Then you get the star. A star will check and push means it will check if there is any other operator. If there is an operator, you have to take a decision. There is no operator, so you simply push it and it will take a space in the stack. C is an operand directly mapped to PFE. So PFE becomes AB plus C. Then you got the right parenthesis. Everything from the right parenthesis towards the left parenthesis will be popped and appended to the PFE. So it has got this one operator, so that will be appended to the PFE, and hence this is the expression. Let's take third example. In this third example, there are 4 operands and 3 operators, out of which 2 operators are such that they have the same precedence. Can you tell me which are those? At division and multiplication, right? So division and multiplication, which one has got the higher precedence? They both have same precedence as per C programming precedence table. All you have to keep in mind that out of the 2, whichever comes on the left hand side will be the first one to get evaluated. So that's how the precedence is set. Out of the 3, these 2 have same precedence. Out of these 2, the one that is coming towards the left hand side, that is division, is number 1 priority, number 2 is asterisk, that is multiplication operator, and then the addition operator. Again, populate the values. Input is string. Initial value is left parenthesis in the stack. A directly to PFE because it is an operand. Operator into the stack. B directly to PFE. Multiplication. Now when multiplication, again you will have to check the stack. A stack has already got division operator. Division operator has got the same preference level as that of multiplication operator. But here we said, since it is coming towards the left hand side, that means that it has got the higher priority. So the priority of slash is more than the priority of multiplication in this example. And even if you consider it, they are of the same priority. Now tell me, if one of the Shatabdi is there on the station, the other Shatabdi is coming into the station, what decision will you take? Will you hold the first one? You will not. You will release the first one first and then allow the second one to go. Similar is the case over here. If I consider that both have the same precedence, then also when our Shatabdi is coming into the station, the first one has to be released. Therefore, you have to pop the previous same precedence operator, add it to the PFE, and then you have to insert the new operator. Then C is an operand directly to the PFE. You have got plus. Now with plus and multiplication, which has got the higher precedence? Multiplication has got the higher precedence. So that means Shatabdi is there on the station, a passenger train is coming from behind. Definitely passenger train is not getting the priority over here. Shatabdi will be moving ahead first and then the passenger would be coming into the station and halting over there. Higher precedence operator is popped, written onto the PFE, and the new operator, that is plus, is inserted into the stack. D is an operand directly mapped to the PFE. then closing bracket or the right parenthesis, everything from this point to the left parenthesis will be popped and appended to the PFE. So at last you will get the plus operator. So this way, using this stack, you can convert any infix notation to the postfix notation. If we talk about the algorithm, so before going to the algorithm, this is the task that you have to perform and submit on the classroom app. Alright. Algorithm. So first step of the algorithm is that I am appending a right parenthesis to the expression. I am pushing the initial value of left parenthesis into the stack. Yes. Then I am reading all the characters of the infix notation. Yes. If I am getting a left parenthesis, then I am simply pushing it into the stack. The second example that we saw, we did this. Then if you are getting an operand, it has nothing to do with the stack, you directly move that operand to the PFE list. If you are getting a right parenthesis, so right parenthesis is making sure that until you get the first left parenthesis, every operator will be popped, but the brackets will be discarded and append to the PFE. If you are getting an operator, then you have to check and then push. Check if a stack has already an operator of the same or higher precedence, then the operator from the stack will be popped, moved to the PFE, or I can say promoted to the PFE, and then the new operator would be pushed into the stack. So this is what you have to do in order to convert any infix notation to the postfix notation. Evaluation of the postfix notation. Now suppose you have got an postfix notation over here, that is A, B, C star and plus. Can I use a stack to evaluate it as well? If I assume the value of A to be 7, B to be 2, C to be 4, then I can write this expression in terms of the values is 7 to 4 asterisk plus. So here what you are supposed to do, that when you are getting any operand, this time you will be keeping the operand onto the stack. Every time there is an operand, keep it onto the stack. Whenever there is an operation, you have to perform that operation on the previous two operands. Let's see how it works. So first one is your operand A. Operand gets a space in its stack. Similarly, A is equals to 7. So 7, I'm just simulating the values over here in the separate stack. Then the next one is B, that is 2. So it is getting populated into the or pushed into the stack. Then C is getting pushed into the stack. Then is the multiplication operation. Now for multiplication operation, since it is a binary operation, you need two operands. So you pop two values from the stack. So you pop C, pop B. You calculate the asterisk, that is multiplication of C and B. So B is 2, C is 4, the result would be 8. This 8 will be inserted into the stack. So where will it be inserted? So you are popping two elements, 3 and 2, and inserting a new one. So the new one would be inserted at 2. So this will be the result after multiplication operation. Then comes the plus operation. For plus operations, again you have got two operands, A and the product of B and C, in values 7 and 8. Again you have to perform two pop operations. You take out the values, calculate the sum, and then you insert the result like this. Just draw the matrix and see. Now the input character is 7 to 4 asterisk plus. You are appending a sentinel towards the end. You are initializing the stack with a left parenthesis. You are getting an operand directly to the stack, operand to the stack, operand to the stack. Then you got operator, pop, pop, that is pop 4 and pop 2, two elements from the stack. Perform the operation, that is multiplication, multiply 2 and 4, 8, insert the result. So push the result. Then again you got an operator, pop, pop, pop 7 or 8, pop 7, perform the plus operation. The result is 15, push result. So result will be there onto the stack. And then you can have a variable like value that points to the top location of the stack. So thereby you can have the answer. Let's see another example. Here the notation is AB, division, C, multiplication, D, plus. So A directly gets into the stack, B into the stack, operation. So operation has to be performed on A and B. You pop 2 times, you get the values of A and B, you divide A by B, you get the result 2 that will be fed into the stack. Then you got C pushed into this stack. Now the operator multiplication, you have got 2 operands. So you will multiply the result of A upon B and C. So first you have to pop the values 2 and 3. You popped, you did the operation and inserted back. So 6 will be the answer. So you have done A upon B into C. Then there is D, operand, push it into the stack, perform the addition and write the result. If we see in terms of the table, you will find that input characters are 42/3 into 5 plus. See the values are written over here. Initial left parenthesis, appended right parenthesis in postfix expression. Operand pushed into the stack, operand pushed into the stack, operator popped both the elements, performed the operation, pushed the result. 3 pushed into the stack, operator popped both the values, calculated the result, pushed. 5 pushed into the stack with the advent of addition operation, popped, added, pushed the result into the stack. And this way you'll get the result. So the algorithm goes that add right parenthesis towards the end of the postfix expression. Yes, we initialize our stack with the left parenthesis and we read all the characters of the postfix expression by using a loop. And if it was an operand, we were directly pushing it into the stack. If it was the operator, we were popping the 2 elements of the stack. We were performing the operation onto those 2 values and we were pushing the result back to the stack. And we had a value named a variable where we are storing the top element as well so that it could be printed as a result. So for now, this is all for stacks. Thank you.